And now it's time to learn how to solve a quadratic trig equation. Dun, 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 dun. Before we get started, just wanted to remind you of the three main steps for solving any trig equation, right? You first want to solve for the trig function, like sine or cosine of theta or whatever, maybe cosine of 3x. And then you want to solve for all values of the angle. That's really kind of a key step, is finding all the values of the angle. That might imply using plus 2 pi k. And then third is solve for the variable. Like if your angle is 3 times theta, then you would still need to divide by 3 to figure out theta. So we're going to do just a couple of problems in this video just to get started here. Here's a quadratic trig equation, right? We're going to try to solve this for theta. Just a reminder that when we put that 2 directly on the cosine word, that really means cosine of theta, that whole quantity squared, all right? I will tend not to use parentheses, but just wanted to remind you about that. Okay, so for the first step, we are going to solve for the trig function. And in this case, our trig function is clearly cosine of theta. So, we can see that it's quadratic, so we need to employ some of our quadratic techniques for that. One way that makes this a little easier if you want to is you could replace the cosine of theta with a variable, such as x. Solving the trig equation for cosine of theta is the same as solving this equation for x. So let's do what we usually do, get 0 on one side and see if we can factor it. So like we've done in many algebra classes, right? Get 0 on one side, we factor, set each factor equal to 0, then solve, and we get two solutions, of course, for x. But we need to remember what is x? X is the cosine of theta, so let's make sure we write that in. So here we have the substitution down at the bottom here. And I decided to just kind of show you if we hadn't substituted for x, we could still, of course, just do the algebra, keeping in mind that we're just treating cosine of theta as if it was a variable, right? I mean, it is the variable at this point. Okay, so now that we have solved for the trig function, all right, we can go in and solve for all values of the angle. In this case, I'm going to have two places on the unit circle where the cosine is going to be 1/2. That would be a pi over 3, and then as always with cosine, it'll be the negative of that. So at negative pi over 3, or of course we could use 5 pi over 3 there. So I'm adding my plus 2 pi k, and then going over here, there's only one angle at pi, right, where the cosine is -1. So we end up with like 3 sets of answers. And if the instructions had said to solve, for all values between 0 and 2 pi, then we could break it down, and I guess it would be pi over 3, 5 pi over 3 here, and then pi. So there'd be 3 answers there. All right, the nice part is about this one, we don't have to go in and solve for another variable, okay? The angle, theta, was our variable. You might recall sometimes we'll get problems where you're taking the cosine of like 2 theta or 3 theta, then you have to maybe do one more thing to solve for the angle. For the variable. All right, let's look at one more example and then we'll be done. So this problem here is a little more like what you're going to see in section 9.2 when they do ask you to solve. It looks like we might approach it the same way we approached the last one. There's only one problem. In the last problem, while this might have been cosine squared right here, this was a cosine here. It wasn't a sine. And unfortunately, we can't say, well, we'll just let cosine be x and then say sine is x. That won't work because they're not the same thing. So in a sense, because the two trig functions are different, it's almost like we have 2x squared equals 3y plus 3. All right, so we can't do the quadratic thing just yet to solve for the trig function. We first need to get our variables to be the same, all right? And the good part is when there's a square, you have a little more flexibility, right? We actually have a relationship that links the squares of the different trig functions together, right? When you see a square, you should always think Pythagorean. So let's write that out. So we know that the cosine squared of theta plus sine squared of theta equals 1. And what we'd like to do is replace the cosine of theta with something in terms of sine, because we have sine over here, and if we did that, we'd have the same function. So we can just solve this for cosine squared, and we get that cosine squared theta is equal to 1 minus sine squared theta. Start getting used to that cosine squared is 1 minus sine squared. It's also true that sine squared is 1 minus cosine squared. All right, so we can just come right over here to our problem here and replace that cosine squared with 1 minus sine squared. All right, let's see if I can get this going. So we have 2 times, right? And then that's just cosine of theta squared, or cosine squared theta. So we'll just replace that with 1 minus sine squared theta. Do I have enough room? Fit it in there. All right. And then that equals 3 sine theta plus 3. So a nice little substitution, and now we do have a quadratic where it's just in terms of sine, all right? And if you want to, you could replace sine of theta with x, if you'd like, and solve this quadratic. All right, I'm going to, why don't you pause the video and see if you can do this one yourself, all right? Push all the way through, solve for sine theta. You'll probably have sine theta equal to a couple of numbers, and then see if you can figure out what the answers are for the solutions to theta. Whoops, looks like I left a theta out of my equation there. I'll insert that in there. All right, pause the video and try to finish this out. All right, see if this is what you got. So hopefully you made it all the way through. I went to work. I first distributed that 2 and then went to work getting 0 on one side. It was factorable, and these will tend to be, of course, if you don't want to factor, you could use a quadratic formula, right, on the 2, the 3, and the 1, and end up with that sine of theta equals -1/2 or sine of theta equals -1, as you can see. And once we have done that, then we're going in and solving for all values of the angle, which I found, and I'll stop there, but if we needed to just find ones between 0 and 2 pi, we could do that now. I think, once again, there would be 3 solutions there. All right, and there was no need to solve for the variable since our angle was our variable. Hope this helps. I know you have at least one problem on an assignment where you'll need to do something like this.